I'm going to talk a little bit about this debate about whether climate change is contributing to the extreme events that we're increasingly seeing, and in particular in the context of the California drought. I am going to talk a little bit at the end about some feedbacks that I think are important that we have to think about moving forward. I'm not going to talk about model projections going into the future. I will leave that for others. My conclusion, I'll start at the end so that when I run out of time, you'll know what I was supposed to have said. The signal that human-caused climate change is occurring is unambiguous. There's a small group of people out there who still deny that, but there's a small group, and we try to ignore them, even if they're in Congress. Some of the most important impacts of climate change, and there will be many, will be on water resources, because the hydrologic cycle is the climate cycle. And there will be impacts on sea level rise, and we've already heard quite a bit about that, and agriculture and human health, a whole range of impacts, but significant impacts on water resources. And California is especially vulnerable because of the dynamics of how we get our water, because of the critical nature of our water system for our economy, because of the fact that we're basically at peak water in California. There are serious constraints on our ability to expand our demands on the system and so on. And there's some unexpected feedbacks, which I'll talk a little bit about. And I would also argue that the scientific evidence that the severe drought we're experiencing now is influenced by human-caused climate change. And I put influence there in italics because some of the debate about extreme events in climate change has asked the question, is this or that event caused by climate change? And I just think that's the wrong question. And if somebody asks you, is this flood event, is this drought event, is this hurricane caused by climate change, tell them that they're asking the wrong question. Causality is a different kind of a scientific challenge. But influence is much clearer. And the comments that Mike made and the comments that Noah made really are addressing influence of human-induced climate change on these kinds of extreme events. So a critical part of dealing with climate is going to be understanding the influence of climate change on the severe challenges that nature poses us. It's not going to be average rainfall. It's not going to be average temperature. It's going to be droughts and floods and sea level rise during storms and that kind of thing. And you've seen these pictures of the atmospheric river and the big storms, and I put the flooding picture up there because we're in the middle of the drought, but soon we're going to be in the middle of a flood. I don't know if it's going to be this year or next year, but California gets both ends of the hydrologic extremes, and we shouldn't forget how damaging floods are. And as unprepared necessarily as California might be for droughts, I would argue we're unprepared for floods as well, or less prepared than we ought to be for floods. And Mike's picture of atmospheric rivers, the dynamic gist that you saw, is much nicer than this static picture. I could watch that circulating atmospheric river picture forever. So I'm going to talk about three possible influences of climate change on California drought, just briefly. One is this question of sea surface temperatures in the Pacific and El Niños and La Niñas. This is an El Niño year, an extreme El Niño year, it looks like. Some of you who've been following this, which is probably almost everybody in this room, know that El Niños probably means, and statistically probably, means wetter conditions in Southern California, but it's somewhat ambiguous for Northern California. We could have extreme floods this year, but I think a third of serious El Niños are also dry in Northern California. So what happens with El Niños and La Niñas and sea surface temperatures in the Pacific is really important for California droughts. And we don't know as much as we would like to know. We do know that temperatures globally are rising. We do know that sea surface temperatures are rising. We do know that there will be changes in the dynamics of El Niños and La Niñas, but we don't really know what that means for California drought. It's a big uncertainty still. And it's an interesting scientific question. There's a lot of interesting scientific work going on that piece of the climate and California drought question. The second one is northern Pacific pressure systems, and Noah talked about this, the ridiculously resilient ridge, which we all love that name, no matter who coined it. And it's related to part of what Mike was talking about. These atmospheric rivers deliver moisture to us, and one or more or one or fewer storms hitting California is the difference between a wet year and a dry year. And this pressure system question is relevant for that because we not only care about how strong these atmospheric rivers are, but where they go. And if we have these big pressure systems that form, and again, the dynamic, the picture that Noah showed with the blob moving around the Gulf of Alaska and the northern Pacific I love that picture, and I'm going to have to steal it from him. That blocks the storms. It shifts the locations of where these storms happen. And so whatever affects the formation and the dynamics and the persistence of that ridge affects how much water we get. And there's some question, and Noah didn't mention this, unless I fell asleep, and I didn't fall asleep, because it was a great talk. There are changes happening in the Arctic with melting ice that some researchers are thinking affects the dynamics of those pressure systems in the Gulf of Alaska. And so it may be that that's another climate change link. As we're melting the Arctic, which we are, as ice changes, as albedo changes in the Arctic, as temperature dynamics change between the Arctic regions and the mid latitudes, we may see changes in these pressure systems. And that's another area of really interesting scientific research right now on what's going to happen to the persistence and strength and location of those kinds of pressure systems. So there's been a lot of debate in the scientific community about the links between those two things and drought. And there were a series of articles that came out, and there was a special issue of the Bulletin of the American Hydrological Society that basically said that there is not very clear evidence that the drought is connected to climate change because of the uncertainties in how some of these things are happening. But the truth is, part of that debate depends on how you define drought. And if we think of a drought purely as a shortfall in rain or precipitation, rain and snow, then there's a lot of uncertainty still. There's uncertainty about these pressure systems and the extent to which they're influenced by climate change. And there's questions about the extent to which climate change is already changing as opposed to will in the future change, El Nino and La Nina dynamics. But the definition of drought as a shortfall in moisture, in precipitation, is, I believe, insufficient. And it's not what the person on the street thinks about as drought. And the best way to think about this colloquially, I think, is that a drought is not having enough water to do what you want, whatever you want to do. If you don't have enough water, you're in a drought. And in that sense, and this gets back to comments that Noah and Mike have already made, the drought is not just a shortfall in rain and snow, but it's an increase in demand for water, sometimes caused by temperature dynamics. And I'll come back to that in a second, and Noah's covered it. But also, I would argue, it has to do with the number of people in California and what we want to do with our water and how much water we demand for the things that we demand. And I just want to leave that message. When you hear this discussion about drought, climate change, yes, no, what are the links, you sort of have to understand what people are talking about when they mean drought, because those definitions also vary. So, drought monitor, we're in a terrible drought. This is last week's drought monitor and the week before and the week before, and it's looked like this for a long time. And for those of you who don't see the drought monitor, Google drought monitor and look at it every week. It's a great map. This is the El Nino forecast. I'm just going to show you some quick pictures here related to the last slide I showed about the structure of my talk. This is going to be a really big El Nino. I think it's pretty clear And in fact, there's evidence now that the El Nino is going to extend pretty far into 2016. Again, flooding in California, drought in California, we're not quite sure for Northern California, for the things that for the Sierra Nevada and snowfall and snowmelt, but it's going to be a big El Nino. This is from a paper in 2015 from Horton and his colleagues. The risk of extreme temperatures over some regions has also been altered by recent changes in the frequency, persistence, and maximum duration of regional circulation patterns. This is partly the ridge. It's a little hard to see, but the red blotches, especially the red blotches, this is a polar projection. This is also an indication of those persistent high-pressure systems in the Gulf of Alaska. And Noah's and Dan Swain's ridge. So, again, other people have mentioned this, so I just thought I'd show this. This is the 4-year running average of temperature for California, showing really how extreme the temperatures have been over the last few years. This is actually, as of July, 2 weeks ago, this is 4 years up to July, showing that not only have temperatures been going up in California over the last 120 years, this is the instrumental record in California, but the last 4 years have been extraordinarily hot. And this is the same thing for precipitation. 120-year record, 4-year average ending last July, the 48-month period ending in July, showing wet and dry periods. The upper part is wet, the lower part is dry. You can see the drought in the Dust Bowl area. I don't know if I can point to it. Oops, not without moving this. No. And you can see the last 4 years have been extraordinarily dry as well. So you put this all together, and again, Noah showed this, but this comes from a paper that Mike Mann and I wrote as a commentary to the paper that Noah wrote in the Proceedings of the National Academy of Sciences. This is an anomaly map. Each of these little dots, it's a little hard to see, but each of the little dots is a year. And if the dot is above the x-axis, it's a warmer year than average. If it's below, it's a cooler year than average. If it's to the left of the y-axis, it's a drier year than average. If it's to the right, it's a wetter year than average. So if there was a dot right at the intersection of the black lines of the axes, that would be a year that was exactly average in temperature and precipitation. And you can see in the upper left, 2014, abnormally hot and dry. And again, Noah showed this in a little better way, although he didn't highlight it. But if you look at the last decade or so, really the last several years have all been in that upper hot, dry quadrant. And so that's an indication of the nature of this drought as well. And again, this is from a paper last week. And see, if Noah and I had talked, I wouldn't have shown it, but this is the paper that actually looks at the role that temperature has played in the demand for water. Again, Noah mentioned it, but the point here is that the temperature effects from rising temperatures due to human-induced climate change have contributed 10 to 20% of the water deficit that California has experienced. So it's the temperature that's in large part driving much of the severe nature of this drought. So for the last couple of slides, I wanted to talk about some unexpected feedbacks, and this I hope will lead into some of the things that I think Ellen will be talking about in terms of water management. Obviously, water is a big deal for California, and there are a lot of impacts of drought on demand for water, on availability of water, but there are some unusual feedbacks that I don't think we fully understand. And this is an anomaly graph. It shows changes in hydroelectricity generation in gigawatt hours per month going back to 2001. Each of the little bars is a month. California gets on average about 10 to 20% of its electricity from hydro generation. And when we don't have water, we don't generate hydro. We generate less hydro. And so if there's a bar below the center line, a month in which we had less than average hydro generation. And if it's above, we had more than expected average hydro generation. So this is actually sort of a drought. It's a wet year, dry year graph. And the years that are below the center line are dry years. And as you can see, the last 4 years have been extraordinarily short in terms of hydro generation. And in fact, there happen to be a couple of wet years in the middle there, but the 4 years before that were pretty low hydro generation years as well. We're actually in 11 dry years out of the last 15 years. So is it a 4-year drought? Is it an 11-year drought? I'm not sure. But I show this graph because we did an analysis at the Pacific Institute a few months ago looking at the economic costs of lost hydro to California. And we calculated that for the last 4 years, Californians have had to pay about $1.5 billion in additional electricity costs because we had to burn more natural gas. Because we burn natural gas is the marginal energy source in California. When we don't have hydro, we burn more natural gas. Natural gas is more expensive than hydro. But here's the feedback. The feedback is burning natural gas produces greenhouse gas emissions. And so we don't think about that much. The increase in greenhouse gas emissions from the electricity sector because of the drought has been about 8%. California's greenhouse gas emissions are about 8% higher from the electricity sector than they would otherwise have been because of the drought. That's a feedback. Now, we can think about this moving into the future. It depends on how fast we build renewables. It depends on all sorts of energy policy decisions. But there are feedbacks between climate, drought, water demand, water availability, energy generation, demand for water in the agricultural sector. There are lots of feedbacks that we don't fully understand connecting all of these issues together. So, some solutions. Again, I think Ellen's going to talk a little bit about some of these things, but I just wanted to frame this a little bit. We have to rethink the way we think about water supply and infrastructure. There are new supply options, but they're not the traditional supply options that we're used to. We're not going to build dams. We're not going to build our way out of this with dams. And the governor had an interesting quote yesterday, which I encourage you to read the newspaper about that. But we also have to rethink demand for water. If we can do what we want with less water, we can improve our resilience to the kinds of droughts that we're likely to experience in the future. And the truth is, even without a drought, we're overusing our water resources. Even without a drought, we're overpumping unsustainably groundwater. So we have to think about demand as well as supply. And then we have to rethink institutions. We need new institutions. We have to manage our water better. We have to think about smart markets and smart economics for water. We have to integrate surface water and groundwater in ways we haven't done and accelerate our management of groundwater. We have to integrate energy, food, climate policy questions, and we don't do that adequately. Finally, I couldn't resist showing this. These are the shade balls that the Department of Water Resources put on their reservoir to cut evaporation and protect water quality in Southern California. I'm not suggesting that our answer is shade balls, but who could resist putting up a picture, and I'll leave it at that. Thank you very much.